Hello, this is Paul from Foster Tech. In this lecture, I will going to show you how to find the probability of events from a probability distribution. Okay, and if we have a random variable, so the most important is to build the table, right? So we call it distribution table or the probability distribution. And if we have that, how to find the event? Okay, all we need to do is find how to find the probability for event. All we need to do is just find the corresponding probabilities and then add all them together. That means if we have a probability distribution and then we have everything, okay, for the probabilities. Let's look at the two examples. The first, can we see this? As I take the same example, okay, flip a coin twice, count the number of heads. You remember this, right? So we have, if x is the random variable that's discrete, right? To describe the number of heads among the two times flipping. From 4.1.1, we already know the distribution, okay? I mean, how many heads? Probably have 0 heads, no heads, right? No heads, or 1 head, or 2 heads. 25% has no, 50% has 1, and the 25% has 2 heads. Okay, so that's the sum is 0 as the sum is 1. This is the probability distribution. Now, how to find this probability? A, having no head. What is this? Having no head means the first, right? Can you see? No heads means x equals 0. If I put it here, no heads means no heads, x equals 0. So the first is just to do this probability x equals 0, right? This is the question. The probability of having no head. And then equals how many? You don't need to add something, just put the one number because this is only one number, right? Okay. The second, having one or more heads. What does it mean? Have one. See, this have one. Or more than one. See, have 2 is also more than 1. Can we see? So what do we need to do? This time ask you the chance to get 1 or 2, right? Exactly. What is 1 or 2? Or from the question they ask you the probability x equals 1 or more than 1, or we can write x equals 1 or greater than 1, right? So this is the notation in mathematics. Okay, and then what does this mean? From the table, we definitely see equals 1. Put x equals 1, right? Or is a plus because this is another overlap. Okay, this is disjoint. You know, this disjoint. I mean, if x get a 1, x cannot get a 2 at the same time. The disjoint use the addition rule. Remember, this 1 and this 1, this 1 or this 1 added them together, which is x equals 2. Okay, the probability of x equal 1 or the probability x equal 2, add them together. Now we know 0.5 the chance for 1, 0.25 chance for what, for 2. So add them together is how many? 0.75. See, 75% the chance to get 1 or more heads. Okay, the third, having less than 2. What does it mean? Is this a probability? The probability that has less than 2, right? Did the questions. What is less than 2? Okay, 1 is less than 2, 0 is also less than 2. What do you mean? The last one is less than 2, definitely we can find it. This 2 is less than, okay, I circle all them together. 1 or 0, this value less than 2, the corresponding probability is here. What do we need to do? Add this together. Okay. What do we need to do is just add the probability x equals 0, right? And the probability x equals 1 together. 0 is a 0.25 for probability. 1 is a 0.50. Okay, it's a 0.50 together. And then the answer is 0.75. The same probability, right? Now you see, this is the first example. So super easy to find the probability. If we, okay, the conditions we have the distribution table, right? This is the most important. Look at one more. Suppose we have a distribution table here, probability distributions already. This is for discrete random variable, x is the random variable, the probability is here, and the first row is the possible value for the random variable, right? The value is 2, 3, 5, 8, 10. The probability is all this. If you add this together, you know the distribution should be equal to 1. Definitely is 1 if you're going to try. Now we look at the questions. That the questions less than 3 or greater than 5. Remember, x is only pick 1. Okay, if it happens, okay, x is only one number. If x is less than 1, and then x cannot greater than 5, means these two events exactly separate, disjoint. Okay, so I hope you understand this. Whatever we look at it. Less than 3, how many less than 3? Less than 3, 3 is not less than 3, it's equal 3, right? So 2 is less than 3. If I go into a circle, this is what we need. First, all x greater than 5. This is not greater than 5. 8 is greater than 5. 10 is greater than 5. The corresponding probability is here, so I'll just circle all this. See, these all this. What's the probability for all? Add the 0.1, 0.3, 0.1 together. That's all we need. Okay, so if I put it here, so the question is this. Ask you x less than 3 or x greater than 5. We just already see. Okay, that's exactly have 1, 2, 3 cases. The first x equals 2 is possible, or x equals 8, or x equals 10. You know why we add them together? Because disjoint, this is all even. And then what the probability is 0.1, the probability is 0.3, the probability is 0.1 again. Okay, and then add them together is 0.5. Okay, 5.5 means 50% together. This is even done. Okay. Okay, we done about these questions. That's all. Thank you.